Awesome. Well, did you guys have any questions about anything?
I don't really think so. Not anything that I really can't probably go through and rewatch like the videos to get more of a refresher or a extra practice.
Yeah. Okay. I felt like it all pretty much made sense. I didn't have too many questions or anything. Should we just start the quiz?
Let's do it.
Yeah. All right, just let me know when you guys are ready.
I'm ready.
I'm ready.
Okay. So when you take a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? So I'd say skewed right.
I would too.
Okay. When you take taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? And that one's normal, right?
That's normal.
Yeah.
Okay. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? It's normal?
Yeah, I would say normal, yeah.
Okay. When you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That would be normal as well.
Yeah. Sorry, something's happening right outside my window. Sorry. Yeah, normal. Okay. What would the distribution of means? Oh, sorry. When would the distribution of means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. That's true, right? Data are drawn from a population that is normally distributed and the sample size is large. That's true too. Data are drawn from a population that is right skewed and the sample size is small. No. Data are drawn from a population that is right skewed and the sample size is large.
That's true.
Yeah. So the first two and the last one?
First and last one.
Okay. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean, about 95% will be within two standard deviations of the mean, and approximately 99.7% will be within three standard deviations of the mean. If the sample size is large, the sample mean will be close to the population mean. And if the sample size is large, the shape of the distribution of sample means will be approximately normal.
I think it's
The third one?
the last one.
Let's see. Describes what happens to the shape of it when the sample size is large. I actually think it's the last one.
That's the last one.
Because the law of large numbers.
Is that a lot of large numbers? Maybe I'm getting them mixed up. They're so close together.
I know, they're very similar.
When our sample size is large.
So how I remember it, the central limit theorem describes the shape. That's basically the difference. It just describes,
Describes the distribution.
yeah, the shape of the distribution.
Yeah.
So do the last one. Okay, use the following information. Okay, let X be a random variable with population mean of 10 and population standard deviation of 6. Suppose a sample of size n equals 36 is drawn from this population. What is the mean of the distribution of the sample means? It's 10.
I want to say yes, you are right.
Yeah, it's 10.
What was that, Deborah?
No, it's 10. It's right there in the problem. It's 10.
Yeah, that's what I'd say. And then what is the standard deviation of the distribution of the sample mean?
6.
That would be 1.
Do we use the formula for that one?
Yeah, you use the formula because you're taking the standard deviation and dividing it by the square root of n, which is 36.
Okay. Yeah, so 6 divided by the square root of 36. So yeah, 1 you said.
Yeah, it's 1.
So regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape, the distribution of the sample mean? That'd be normal.
Normal, yeah.
And then 12, what theorem would justify a response to the last question? And I'd say the central limit theorem,
Right. That's what it is.
because that describes the shape. Cool. Submit that. Nice. That was easy. All right, well, do you guys need to talk about anything else?
I'm good.
No, I don't think so.
We're good? All right. Well, that was good, guys.
Yep. Guess
And I'll see you on Thursday.
Sounds good.
All right, sounds good.
see ya.
Okay.